let's get going. So what we're doing here is we are creating. I'm trying out new ways of doing the monster AI stuff. So traditionally, before I have basically have sort of an amalgam of different styles of things, like sort of like overrides and default, default behaviors, having things like can aggro be a sort of a magical property on the monster, which you set to if it's gonna be able to aggro or not, and walk speed and stuff as well, and max health and stuff. So a lot of things have been sort of magically connected through just arcane, and each feature is basically has a different way of setting it up. And so I want to go from that to a more, I guess, streamlined way. Well, I don't know if streamlines maybe the best way to put it, but more easy. Like the goal is to get a more easy way to sort of implement a new monster, and also maybe even edit a monster that already exists. So I've always been the fan of having the control of what is happening. What you would say, as much visible as possible. So that is to say that you have let's say you have an update function. Let's take this function, for example. Now everything that is in here is what is actually the entire update function, you could say. Well, most of it anyways, for this monster. And so you can see everything that's going on, you can see in here. Instead of having a fragmented way of doing things where you have a bunch of systems that looks at different components, and we have that as well, but really this is for specifically for like the monster AI stuff. But we do have stuff that is common among all entities, like destroying an entity and other things like that. But this is specifically for like the state that the monster is in, to handle like the AI and stuff. And so what I want to do is go from this way where this stuff was actually like governed from outside of the monster, and depending on certain variables it was behaving in a different way. But now we have this state machine struct, which purpose is to define a bunch of state update functions. So we have, for example, this walk, which takes a state machine, and we took a look at that pretty soon. And we have the registry and entity, and this allows us to basically access anything we want in the entire game. Well, the registry does. This is the easiest system where you can access basically anything, any kind of data that you need. The entity is the current entity. This is the monster that we're currently dealing with, currently updating. And then we have the timestamp as well, which is not used in this case, but we still need to define it, since this signature here is the required signature for all the state update functions, like state machine update functions. So it's basically like it's a function type basically that we need to adhere to in order for this to work. And so how does it work? Well, if this is the current state, the state is now a function. So let's say walk is the current state, which we are setting down here, by the way, somewhere. Here's the state machine. So we're creating a state machine, and the current state is equal to the walk state. So we're providing the pointer to this function. Now this, because I didn't come up with this. This was a pattern that I picked up. I don't remember where I seen it. I think it was on some YouTube video, but I thought it was a pretty genius way of doing things, and pretty bare bones as well. I'm gonna show you the state machine system as well, which is very simple. And so the state is now this function, which means that basically when you update, you call this function, and that's it. And so everything that's in here is either gonna, well, you can do whatever you want. You can get other components and change them in however you want. My idea is that I will fill these with sort of helper functions that sort of describe what is happening. So for this, for example, we're in the walk thing, the walk state. So the first thing we need to do is, for this example, we want this monster to be able to aggro the player. So basically, if we're within a certain distance to the player, which is this aggro distance, then we change our state to aggro. And so, because the state is in this part here, and so we're basically, yeah, we're setting the new state to be this aggro state, and then we're doing the rest of this stuff. So but if we're not in the distance to the player, we do a default walk update, which is basically just well, we can look at this. So basically it's gonna turn around if we're at a ledge, so we're about to drop from the ledge. Hey, morning, Michael. How's it going? Yeah, I'm just explaining an idea that I have here. So, and I'm trying out for like a state machine for the monsters. So this default walk update function, basically we're turning around if we're at some sort of ledge or we're blocked. So basically the monster is basically like the Koopa in the red Koopa in Super Mario Brothers. Or we apply we apply a horizontal move force as well, which basically, yeah, we're walking in one of the directions there. And that's basically that's the default walk upgrade. And so so that's the walk. So we can turn into aggro state, or otherwise, or yeah, and we do like a walk default walk update. So this is basically how the system works. The state is just a function that we call on update. And so when we set the state to aggro, next frame we will call this function instead. So now we change the state to aggro, and what we're doing here is I have this face player function, helper function, that makes this entity face whatever direction is needed to face the player, and then well, horizontally, that is, and then just the default walk upgrade. However, now we change the speed as well, so here we can specify the speed. So now it's an aggro walk speed, so now it's like we're moving a bit faster. And how that looks is here. So I will start the editor. Let's see. I've already tried this, so it should work. Connect the controller as well. Alright, so here's our debug thing. Oh, it crashed. Was there some issue with the code that I just did, or why did it crash? Oh, maybe I started to update something but didn't follow through or something. Oh, I see. There we go. Yeah, I updated a little bit here. And right, this is animation.animations. But wait, but now that it, no, hang on. Oh, this is nullable. Oh yeah. So this is animation is gonna be if this exists, we will set this to that. Otherwise, it's null. There we go, I think. Yeah, I changed here a little bit. I made the initialization of the monster a bit easier as well. Yeah, I'll show that soon here. So let's try this now again. Here we go. Alright, so here's the monsters. Now it's in the walk state, and it's in the default walk state, default walk update, and now it's in the aggro state. So now it's gonna follow me around here. Okay. I was thinking of using tag unions to make states. Maybe it will not work, but I will try. Yeah, I mean, I did that first as well. And it does work pretty well, actually. Because you can also attach state to... Yeah, it's like a... It's an enum with state. So it's really nice because you can have state with it. So, yeah, that's what I had first with my pattern. But it sort of turned into this mixture between override. Well, you can. I mean, of course, you can build it in a different way. The way I built it, maybe was, well, it was turning into this monster of very specialized. Well, I guess very mixed sort of patterns everywhere. So. It was beginning to get a bit hard to reason about, I would say. What I want is like, is this like, because this is, you can copy this. This is the entire behavior of the monster basically. So you can copy this if you want to copy a monster, and that's the entire thing. And you don't need to, from what I had, you don't need to fill in a bunch of switches everywhere, which is it was just that it took a long time to actually get to a starting point for each monster. So that's my reason to do this. And I think it's pretty nice also because, as I said, you see the entire update function here. You can see everything, and that is I think it's a really nice thing. So it's basically just the update function is this entire thing, but then everything that happens is sort of condensed into these functions, like helper functions. Could you not add a tick inside of the states and call only ones from inline else? Yeah, so you can. So I tried to do a little bit like this. Let's say we have a state machine, something else, and then, well, it's a union enum. And what you can do is you can have walk, and maybe you need some state for that. I'm not sure. Let's just do no thing for now. Well, you can actually, yeah, you can have a struct and then function tick or update or whatever. I usually call it update, and then you usually want these things. Let's see. That's an update function like this. I guess it could be public or it has to be public, and then you do your update there. So that is also one way of doing it. And then let's see, and this thing here, and then you have a update function here on this entity, and you would say, and also you need self. I guess this would be you could also have the specific states here as well. So this would be like this. So self, you would be able to update the state, and the state is the current sort of state. If you have any extra state like walk speed, or I don't know what you want to have, like something like this. Okay, and then in the update you would do switch on self, inline else, and then you get the state, which we need to have mutable there, and then you get the tag, but you don't need the tag really. And then you just do s.update. Well, actually, well, we changed the. This is the state machine. This is self. There we go. So now we can do, because otherwise you couldn't do this like s.update. And then you can say self reg entity t. All right. So that's very possible, and yeah, that works as well. So now this function will call whatever function is in here, and you can add whatever state you need here as well to these things. Yeah, that works very well. Yeah, it's especially good if you need state like this and want to be able to use it. So this is basically the same thing, except we don't call this intermediate sort of update function, which finds the correct function inside. And also, like in here, like if let's say you need some other state or whatever, it's actually gonna be, we're actually gonna be able to fetch this state. Like let's say you need some specific state for just walk. Well, either you could put it in this struct over here, which is sort of the monster state. So you could put it in there, or you can create a new component, which is like the walk component. And I don't know, walk speed, something like this. And then you can use that here, so you can get this from the entity. And now you can have a state. Oops. Now you can have the state and, you know, use that like that as well. So it is possible to just add more state there. But really, this is like everything that is actually needed. And if we look at the state machine system, like this is the ECS part of this. The component is basically, the only thing we have here is a state function, which is a pointer to a function, which is a state function, which is this in the shape that those functions were. First you have state pointing to a state machine, which is this one, so you can change the state. And then you have the registry and the entity and the timestamp. Okay, and then the system is very easy here. We just have a update function that needs the registry and the timestamp. We create a view, so we're going through all the state machines in our we're getting all entities that has a state machine, and we're grabbing out this specific state machine for the entity. We are then just calling the state function with these things, and that's all you need to do for this to work. So it's a very simple system here. And then one of these functions are the state. So if it's walk, the walk function is going to be called. And then to change the state, you simply do this. You set the state to the new function, which can technically be any function that looks like this. But yeah. So yeah, that's the idea here. And we'll see how it turns out. This is my first test implementation here, so I mean, it obviously it works, but we're gonna see how it plays with, building on it with more complex states and so on, more complex behavior and stuff. But it's kind of modeled after what I remember in Unity with, I think it's like it's a state machine for the animations only. So basically you set an animation based on, you go from, so you have one one animation playing, let's say it's like idle or something, and then it goes to walk depending on certain conditions, and that's basically what we're doing here. But the difference here is that you're doing it with just programming, just basic programming, procedural programming, and not configuration. Basically is what this is. This is procedural programming, because I was thinking of also like making this configuration based instead, where it's more like declarative on what you're doing. However, this is kind of sort of declarative. Like if you think about it, like the functions are being called, but they are sort of named like this. So it's very terse. So you kind of get the same sort of structure as a declarative approach, but it is procedural. So yeah. So it's kind of, you get the best of both worlds, I guess you could say. Because now if you want to edit something here, it's very easy to think about, okay, how could I do that? Well, we'll see. As I said, we'll see how well it works in the future here. But yeah. So yeah. So what I've been doing is making it more easy to do these things. And one thing, for example, is how we're initializing a monster. So before, it was part of this monster AI system which grew into a monster. Excuse the pun. And let's look at that. The monster AI system, it's just called monster here. So basically, this is kind of the other way around, because this has to know about everything basically. So it takes in everything. Well, this is part of the monster type actually, so this could be sort of moved into something else, except we don't really need this type anymore. If we implement everything in the new way, we don't really need this huge monster type union enum with a bunch of functionality for everything. So instead of doing it like this, we have it, we like invert the control to the monster struct instead of having this sort of shell around the monsters. There's still some, shelling going on with if a monster dies and stuff like that. But so there are some generic things that apply to basically everything. But for monster specific things, then it should be handled by the state machine thing. Well, the behavior anyway. Alright, so, and here you can see like handle hunt player, like this was called from the monster AI system. So we had like monster AI components, one component for all different kinds of monsters. And then the monster AI system would call this handle hunt player, which is basically just calling this function if it exists. Otherwise, we don't do anything. So we had this whole bunch of things, and at the end, this is like 1100 lines of code, but all like very sort of generic and also specific functionality for all different monsters. And there was starting to become very unwieldy, even though we have things like the help from the compiler, where if we have a switch here, for example, these cases would, if we add a new monster state, we have to handle it here. And here we're also switching on like monster type. And so basically here is like, okay, we have a fly state, which is like these states were also common for all different monsters. So it's like for every monster that doesn't have it, we have to add it to this list and then say that, oh, it's not implemented and crash. Instead of doing it like that, it's now handled all inside of the monster struct itself, so you can see everything that is going on. So we're kind of inverting the functionality, you could say, the responsibility of the logic. So the goal is to have everything that happens in here is going to happen in the monsters themselves. And what I've done is basically I've done the walk thing already. So all things that happens in here I've now moved out into a new function, which is over here, and it's the default walk update. So now you can call this function and have the same behavior be applied. And so instead of having the function be called from a system around an entity, instead the entity itself calls this function to have this behavior as easy as possible, as accessible as possible. But yeah, that's the idea here. And as I said, the pros about this is that we can now more easily see the entire thing. We can see everything that is going on in this state machine, and hopefully it won't be too bad. But I think it might be easier to make more specialized behavior like this, but perhaps also easier to just copy default behavior as well and change things. Like if we don't want to aggro, we just remove this and remove this, and now we don't have aggro anymore. So it's not really the goal is to have very easy, fast way to implement things. If you need to implement a new thing, then you have to do some work for that, but it's not gonna feel like you're doing perhaps the same thing over and over again. Yeah. Anyway, there's always gonna be, a little bit of friction, but hopefully the point is to reduce that. All right. Yeah, so maybe I'm thinking I probably want to sort of implement this in the first monster that we have, the mossing. Now, the way this works before is that, as I said, now this is sort of handled both in here, but both also a lot of stuff is handled outside in the AI system. And so here we're calling a monster AI system in that monster, but now instead we want to call, actually we want to first create the entity ourselves this time. Okay, that's the difference. Not that huge of a difference, but then we also want to import monster utils. Now I'm thinking of actually adding it to the library here instead. So let's add it here actually. Monster utils. Sure. Oops. No, that's it. All right. So now we can access it. But I think maybe we want to have this convention here just to make it less things to type and to look at. Alright, so down here we'll do monster utils and init monster instead. Now we'll get these unknown types. I'm not sure. It's something to do with the LSP. It doesn't really work right now, as usual. After the update to 0.15, I would say it stopped sort of working properly. Okay, and then we have options. Now this is a bit interesting because here we can specify different options for the monster. So instead of that being almost the same every time, we have a way to sort of define options. So if we want damage on touch, we can say it's gonna be true. We can set the max health, death settings, drop on death, which collision groups, and so on. So there's a bunch of options that you can put in, and this is also extendable. We can just extend this thing. So we basically, it's a little bit of configuration style happening here. Draw layer we have to provide. So there are some things that we have to say, and some things that we don't. Most of the things we don't really have to worry about, actually, because they are like default things. So here we have hitbox, and we should have a hitbox here, yes. Alright, so now we basically have the same thing as we're doing down here, except we're not adding the monster AI component as well, because we're not gonna use that. Now for this monster we have a temporary sort of special case here where it's the monster spawn, or the boss spawn, I mean. And so let's see, what do we want to do here? Okay, so we're removing that. We're getting the body, and we're doing some stuff here. We're getting the monster. So this one won't work anymore. We don't have this. Oh yeah, this is only used for setting the state. So what we can do instead is get the state machine. And we set this. We set the state to be mossing state machine dot spawning, I guess. Alright, now let's get rid of that. Okay, so that's basically what we need to do there. And let's see, health, we change that as well. This one, let's remove that. Okay, there we go. So yeah, okay, so this should still work. Yeah, animation container. Oh yeah, so we also need to provide animations. Oh yeah, we need to provide the scene entity. This is also a bit different here. Now we need to change this into this, so we can get rid of these things. And this one is gonna be animations, is animation container dot mossing, and entities scene entity. No, this is scene entity. That's the entity. That's like the information from the scene file. All right. Position is scene entity dot position. There we go. Oh yeah, this doesn't exist, so we have to create the. Now I have to create the state machine, which is just a struct of functions that like update functions. So the first thing we had was spawning. Let's go over to our other monster, so we can copy this signature here. Alright. And yeah, we'll figure this out. So it's basically gonna be stuck at the spawning state for now. But we also need to add this thing. So we're adding to entity. We will add a mossing state machine. There we go. So now we have that. No, wait, no, that's not what we're doing. We are adding a state machine with the state set to spawn, I guess. Or actually, we have another state called waiting to spawn. Now this is going to be basically a lot of copy paste with waiting to spawn. This was what I was kind of afraid of, is because this function is basically going to be the same. However, the solution sort of to that is to have a default waiting to spawn function that we can just call like default waiting to spawn, and yeah, we need, I don't know if we need T actually for that. Well, we'll find out. And so it's like if we have spawned, basically we want to change the state to spawning, like something like this is the pattern that we want to have. All right. And when we're spawning, we also want to have like default spawning. And if we're done, then we want to, I don't know, go to idle or something, or walk. I guess we'll have a walk. The nice thing here is that you can copy a new state. You don't have to change the signature. You just have to create a new, like, copy this thing. And so walking. So this one is basically just walking back and forth. So we can basically just say default walk update. Maybe we'll get rid of the update, as it's kind of like implied. I don't know. And now we have a walk speed, get walk speed. Whoops. Right. Well, okay. I'll just say that we have a default walk speed of this. For now, we'll figure this out. Right, and that's it. Now we're stuck in this state here. And we don't need to change the state anymore. There we go. And this will be walk. So this is kind of the transition, like these are the transitions. You can also set other state on that based on the things. Like for example here, when we spawn, we might want to start walking in a random direction. Right now it's like whatever direction we had from before. Maybe we can set the direction randomly, I guess, somewhere over here. I think you can actually set the direction here to be random. There we go. All right. So now we just need to implement these functions, and then we basically have. See, that was kind of easy actually. We changed this monster now. We basically removed everything that these 1100 lines are currently doing, basically, and we're doing it here instead. So yeah, that's a huge, you know, I think that's an upgrade to me. We'll see in the long run how good it will be. All right, so we need to implement these functions now. Default waiting to spawn, default spawning. I'm gonna go ahead and change this to like default walk. All right. Now default waiting to spawn. We can basically just go in and copy. We can. One second. We can basically go in and copy the function that we already have in the monster AI state. And here we can see basically how we're doing like the inversion of this. Because we're taking functionality out from this shell and putting it into separate functions. And then those are called from the entity instead of this system calling stuff on the entity. Let's see. So we have... Where is this? Waiting to spawn. Here we have the update function for waiting to spawn. So we basically just copy whatever is in here and we move this to here. We should probably have been functions from the start anyway, but yeah. Now we're doing the work. I've been putting off a lot of stuff, but it's basically just because I didn't want to prematurely refactor and I wanted to see a pattern emerge before actually finding out, okay, how can we redo this in a much better way. And I think it's probably worth it to do it like this. It's gonna be sort of like a test as well. Alright, let's see. We need player body. Okay. So we need distance. Right. And we could also add like a, you could add configuration here, like how much distance is a spawn distance, But what I'm gonna do for now is I'm gonna put this. Oh yeah, I did play around with this aggro state. It turns out we don't actually need this, so I'm just gonna remove it because that state is enough to, the state function is enough to actually do that. Also, I'm gonna change all these capitalized sort of C-like defines into just, the same as everything else. Default spawn distance threshold. Let's see. Oh yeah, we got default spawn duration. Not sure what that is. Let's see. Default spawn duration is 1. Okay. Yeah, aggro state. So this won't work. I'm not sure if I actually use this. No. So this whole thing we can just delete because what I did was I started out with this, and we have an aggro state, and we have a distance to the player, and we're checking that, and we check. So very, very specialized for aggro. What I did instead is I'm just have a function that checks if we're what distance to the player. Like if we're close enough to the player, and then change the state to aggro. So this whole function actually turned out to be, we're using this function instead. And then if that is true, we just change the state to aggro. So that was all we needed to do there, which was a really nice optimization or refactoring. Default win response. So this could be the same thing. Like, we don't really need to get this thing here. We can just say if distance to player is the default spawn threshold distance. Now, yeah, we have these set animation, play sound, spawn duration, default spawn duration. And now this part is gonna change. So now we actually return true, or we could return the spawn duration, I guess. Well, now this is the point of where it's gonna get a little bit more complicated, because now we need a little bit of state to know what's going on. So let's just say that we return true instead of this, right? Because true means then that, okay, we need to trigger the spawn state. If we don't, we return false here. I guess we can invert this to say if we're not within distance, we can return false. Otherwise, we will do these things. Okay. We actually need T here, so let's add that. Spawn duration. So yeah, I'll do this for now. Okay, so we'll go back here. Now we have this function, and at this transition we want to also store the time at which the transition happens somehow. Like, that's the end. We need to know when the spawning is gonna end. That's the thing. And the problem is here that this state is basically, it's gonna be common among almost all monsters. So I'm gonna think about how to do this. Now this is one thing where it would be nice to have this. It would be nice to have this as a union enum, because now you can add more state to the spawn, waiting to spawn state, or spawning state, sorry. Because this is really what needs to have more state here. So I'm wondering, I mean, without changing it, this entire thing to a union enum. And as I said, what you could do is you could just add a struct here, which is like spawning state or whatever, and then you have ends at, and that's a timestamp, and that's it. So you can at this point you can actually add this state. So you can say add to entity. I will add a spawning state where ends at is t plus whatever spawn duration we get up here. So this is also a nice pattern that you can use if you have an if like this and you need some state out of it. You can just add this, and from here you say question mark f64 instead. So now it's sort of like it's like a transition from a bool to an optional if you need some more data, if it's true. So here we can return null instead of false, and here we return the spawn duration. We could also bake in, yeah, it's probably better to bake in the behavior here actually. But I will just go through with this for now and see, because now we can do this spawn duration. Okay, but we probably want to make this into a common thing that happens every time in the default waiting to spawn, you know. And so we'll move this spawning state to here somewhere, and then instead of doing this, we move this to here, and we do this. Yeah. And we don't return spawn duration, we return true now, and here we return false. Boom. Okay, so now that happens like every time, because now we don't need to sort of re-implement that in every time we want to have a default spawning state functionality here. So we have waiting to spawn. Now these two are basically going to be on every type of monster. It would be nice if you could just, you know, have this sort of automatically been added somehow, but I mean, I get it is sort of possible. Maybe. Actually, maybe it is. You know what? Let's have like default spawning state machine. Because the functions are the same. You could put these in here, right? And then you can even have what state will it be? This is a comp time thing, so that should be fine. I don't know really what type this is gonna be. This is the state that we'll have after we're done spawning. So I'm not sure what this will be called. After state? I don't know. After spawn. State after spawn. Okay, this is a bit of comp time magic going on here. I'm gonna try this out. Alright, now we just set this here. Okay. T. You need T, so add T there. There we go. Now we don't need to specify this on every monster, I think. We can just do... well, we don't even need to add it here, actually. What we can do is we can say... I mean, you can if you want, I guess, maybe. I guess you could have... initial state is gonna be default spawning state, where this is where we're spawning into walk, and then this is like, yeah, waiting to spawn. And we can even have a declaration here which is like default state waiting to spawn, so you don't have to know which is like the default state. Default state or initial state maybe. There we go. All right, initial state. Yeah, this is the initial. Then down here, when we create this, we just say initial, and that should work out, right? Because the state is just a function that looks like this, so we can have these things. We can have, yeah. Okay, let's move this into monster utils somewhere. Man, I'm beginning to like this more and more. Pump function, there we go. Yeah. And now this is monster utils, default spawning state machine, the initial state. And if you ever want to have specialized functionality, you can just go in here, basically copy these two, and modify them however you want. And yeah. Oh, now these are just this. Cool. State after spawn. Unused. But it's not unused. Okay. Anyway, I think if we implement this, maybe the error will go away. All right. So default spawning. Yeah. Just a spawning update. We need to move this from here now. Spawning is a state. The update function here, and here we have the spawning. So basically everything that happens in here, we'll move this out now here. It feels so nice to refactor like a monster like that into such a more like nicer system. It still remains to be seen if this works properly here, but and it's like, you know, better to work with and scalable and whatnot. But I mean, initial thoughts is like it feels pretty good. All right, use of undeclared identifier spawning. Oh yeah, that's the state. That's right. So now we can get the state because we know we have the spawning state. So we can just get the spawning state with this. All right. And I believe I call it ends at now. Let's invert this if here. If it's less than spawning ends at, we return A little bit less nesting. Right, so here we also an example of like, okay, it's mixed, like generic mixed with specialization, this part. So we're looking at, okay, is it this one? Then we need to do some extra stuff. So, but this is now gonna be moved into the specific monster that does this. So I'm just gonna remove this for now. So now we're calling set idle, which is basically just saying we wanted the default state of this monster, but we don't really, we don't want to do that. We just want to say return true here, and here we'll say return false, which means we should return this. Really, so a lot simpler as well. All right. Oh yeah, hang on. Oops, no, not this one. Here I was. I'm gonna open up Twitch chat in a separate window because I don't have like. I always forget this. I'm pretty new to streaming. Like notifications and stuff like that. I don't have it. Okay, I have to wait on that. Whatever. Okay, so now we have that function there. I don't really see what is a dinosaur you're posting there, Michael. Let's see. Yeah, back to this part. Okay, now it's not complaining anymore, so great. Yeah, so we have this default spawning functionality basically that we can call. There we go. Now we have the notifications up. And great. So very easy to now provide with this initial thing. And as I said, if you wanna do this, you can. And also, if you want a specialized, like let's say, waiting to spawn is the same, but you want a specialized spawning state. Maybe actually what you could do is have a default spawning state machine options, right? And so state after spawn is well, we can add this options afterwards, because that one is required. Also this should be comp time. But what I'm thinking is I want to add, if let's say you want spawning to be something else, we can say spawning state, and we'll make it into a nullable state functions null. So if you want to change that, you can. And so here you can say options spawning state, or else we do spawning. And since it's comp time, this is actually not like a runtime check or anything. This is gonna be like we know beforehand which is gonna be. So that's really nice. Yeah. And yeah. So now that, and the reason for that was that yeah, if you want to specialize the spawning function or the spawning state function, yeah, you can now specify that in the options. So now if you can just provide your own spawning state function, and it will do that. So then we support that other pattern where we had a specialized thing with the spawner monster. Okay. Let's see. So here we can also provide max health. There we go. Is there anything else we can do here? Which is nice. Also here you can like, okay, now I can you know, see what I can add here. It's a pretty nice pattern where you have these sort of options things. Okay, now let's see. So let's think about this one. Get walk speed. How would we implement this? Also set idle. We don't really have anymore, so we can just remove this. These ones we don't need. This we can use the default implementation that was for like checking for ledges and blocking stuff. All right, so the walk speed is though a bit different. Now what we could do is maybe we could set the walk speed to be a thing here and set it to 300 to start with. And if the reason here is that, let's see, where's the thing? Oh, we don't actually add this type, I don't think. Oh yeah, wait. So, oh yeah, so it's, we're also adding like the monster type component. I forgot about that. Oh yeah, here we can say walk speed if the reason is forced. Well, if we have a reason, then we should set this to 600. No, it's 300. There we go. Okay, but we're not actually adding this thing here, so we should add this guy here with the reason there. Whoops. Because that was like automatically done in the previous sort of version. But now we have to do that, so but that's fine. Now we can like choose if we want to add more like this state here. But now we have this walk speed. It depends on the reason here. So we set it once. We don't need to call a function every time. But we do need to get the walk speed here. So we do need to get this guy from entity. And we can now say this instead. Okay. And now we can also remove this function there. There we go. All right. I think we basically did everything for this monster. We'll see if it works. So yeah, let's try and run this. Took so long to compile the build script for some reason. Sometimes like it feels like the Zcash is basically clearing itself after some time. It's like even if I have, it feels like even if I have compiled it, it still runs the compile, like it builds from scratch sometimes. It feels like after I've what is it, like in the morning, like like yeah, in the morning, like the first time run in the morning, it like takes longer for some reason. Okay, now we're getting an interesting complaint here. Let's see. Oh, because this doesn't exist anymore. I mean, let's just add this. I'm gonna replace all this probably. We're gonna make like have a trial period for this, and there's a default walk speed. A trial period for this pattern, and we'll see. $893. Oh, that's right. Well, since we have this function already, what I think I will do is I will remove this function, and I will call monster utils turn, where is it? Default, no. Oh, it's not public. Turn around. No, let's make this public. There we go. Spawn 228. Right, so now you need just the entity instead. That's actually, you know, I should do this for all the monsters, really. Just replace that. Alright. Missing 18. Okay, so what do we... Oh, now you need options as well. So you can just provide an empty options, and that should be good. As long... I don't mind providing an empty options. It's like, as long as it's easy to sort of default it using the default value. Okay, so here we go. So now we got some interesting error here. Expected type pointer to a function. This is a pointer to you know, a state function here, and we found a pointer to a constant state function. So yeah, so we need to change this type. This type needs to be a constant. I believe this also could be a constant now. Should be a constant there. And I'm not sure what the difference is because it's a function, so you can't really, you know. Well, maybe you can change it. I don't know. There's nothing on the function to change, as far as I know. It's not a struct that you can change the fields, you know. Monster utils. Unless you can do like dynamic programming or whatever they call it, like yeah, mutable function. I don't know. Let's see. Expected rearmament from 2 default spawning. What did you need? Oh, timestamp. All right. There we go. I mean, basically what we're doing is like good old, you know, moving things out into non-repeated functions, places. But you know, having the state as a function turns out to be a really nice pattern. It's very, you know, very flexible. Really cool, actually. What is this now? Struct no member name spawning. Mossing state machine spawning. Oh yeah. So this would. Oh yeah. Wait, spawning. Why would be? Oh, so I want this to be directly into spawning, right? Well, let's just have a temporary, you know, thing there. This should be, you know, the same thing here. That's the spawning state. So now we should have that available there. I mean, I guess we could also copy. We could also do like, well, whatever, that should work. It's a temporary code anyway, so because I'm gonna move that into a separate into a separate monster. Okay, 58 aggro state. Yeah, we don't need that anymore. That doesn't exist. Let's see now. All right, so we're spawning. Oh yeah, so I want to go and see if the monster works. There we go. Yeah, I turned off the sound for now. Okay, there we go. That's the monster. Oh, it's quicker than usual. And the animation does not seem to be playing. Also, there's some weird, like, pixels going on like that. Okay, so it doesn't work as there's a couple of things that we need to do as well, I guess. First thing I want to check if we get any like error messages or not found, could not, I don't know. No? Alright, so let's go to the monster AI system. So there's a bunch of things here probably that's happening that we don't take care of at this point. Because now we coupled away this entire system, which handled basically everything for the monster. So there's bound to be things that we did. So it doesn't have like attacks or anything like that. Let's go to, let's see, damage player if in no, that's not. That's if it has an attack. Apply knockback. Where is that happening? Is knockback. So here we have like, yeah, check pending damage. This function is a bit different actually. This is actually being called as an update function in the game update. Like, so the yeah, check pending damage. These are functions that are being called here. And this is all like the systems that we have. And the reason for these is to, well, what is it? I guess remove pending damage. So the way it works is if the monster is hit, we add pending damage, and then the health system sees that, oh, we got pending damage, so we actually do the actual damage there. And what we're doing here, we're checking if we have pending damage, and then we play some sounds and stuff. And we do some effects like knockback, cancel attack if hit. So there are a bunch of like things here. Create animation for spawning. Yeah, so we're creating hit particles as well. So yeah, so this behavior we do want to have as well. But this is kind of it's kind of common for all monsters, and maybe it's like we move this. Maybe we don't look at this component. We look at something else. Maybe we'll move this into a separate component. I'm not sure. How can we do that? Because it's not really, you know, a state per se. Yeah. I mean, we do have this as well. It's a bit all this is like where the system becomes a bit more complicated, because the update function is just called in one phase of the whole all the update steps. Like it's just one of the steps. But here we might wanna be running a separate update function, which we are doing here. Is like the check pending damage function is like a separate step that needs to be called at a certain point in time to handle the damage being sent here, because otherwise the health system will remove the pending damage, and yeah. So yeah, this requires a little bit of thinking of how we should structure this. Also, we got like little things like this. Can aggro something player. Well, actually, let's go back to, could we make this work in a different way? So we got like damage on touch, destroy on touch. Where is like the monster actually being damaged? I think it's in here actually. Maybe, or maybe not. Okay, I'm gonna search hurt. This is where things are happening. Hurt damage, monster. Okay, so it's happening in the player update, where we check if the player is like attacking, and then we get an attack hitbox and stuff. Maybe we need to, maybe I need to like rework this entire system, because it's like maybe it's like let's see. Let's say we have let's think about this another way. So let's just do this. So let's say we have first we do attack, so we have like the damage, and then we have also like invincible system as well, so that will also come into place, invincible. And then, because the thing is, at this point we know that we have the attack, we know that we have been attacked, and then invincible, and then here if we do the monster update here, state machine update, we know at this point if we've been damaged or not. So why not just do it like this? I'm not sure. I think I just made it like that because it was convenient at the time. And then we have the health system remove the pending damage and stuff. Because we need to run this before health, but after we know the damage. So yeah, I think that should probably be enough. I'm just gonna have to think about what could this cause. Like, why do we need to run this before? I don't know. I think it's because we're baking in the player damage in here as well. So maybe we'll move out those things into the damage system or something like that. Make a new system called damage system that adds pending damage to things. I don't know. Or attack damage or something like that. Attack damage system. Like here, players getting hit because of what? A projectile? No, an attack. Yeah, this is an attack. So we can move this into an attack system. This part. Yeah. Alright. Let's do that. I think that makes more sense to solve this thing here. So we have like an attack system. Alright, so we have an attack component and an attack system. Now, my idea is that the attack component will have state, which is basically gonna say, okay, here's the rectangle where the attack, like the hitbox for the attack, the damage, maybe you have the source and the types of target that it could target. And then the attack system will basically say, okay, grab all those, check for intersections, and hurt whatever thing is there. All right, so we'll do that. All right. There. We need C. All right, so we'll go through attacks. No, component. And we will loop through those. Get the attack from that. So this is the attack component. And then we'll say get intersections, all that. So now we can basically just go to monster. We can copy this whole thing, brew. Let's just copy all of this basically. And well, we can have like update attack, I guess. Gonna say any type for now because I don't have the thing. Alright. Oh yeah, oh yeah, it's attack component. Attack component is actually a thing like that. There we go. Alright. But this is specific for the player, like a monster attacking the player. So it's a little bit different, but I think we can sort of maybe kind of bake in all the behavior we need into the component itself. Depending on the target, like if the target is player, then we can take these things into account and stuff like that. So we also need to be able to get the hitbox, so let's do that. This is the function for that. Let's see, get the hitbox. I mean, I guess we could. Well, don't necessarily have a monster AI component, I guess. If we have one, we could get it like this, I guess. Let's move you over here and do. Well, we don't have a AI component. We'll have an entity and registry, and then here we'll say monster type is equal to register try get, because we not necessarily have it. And now we can say monster AI component from the entity, and or else we return null because we don't have one. Alright, and then we will look at, no, this is monster AI, so at the type, and we'll basically do the same thing here. All right, and then we have attack type, and this is interesting because we don't really. I guess we don't really have that, but we could add. I guess we could have like source is attack source. And make this into like, first we have monster. And so we have an attack type there. I know this type looks ridiculous, but I don't care right now. I'll fix it someday. Don't think it's important right now. But that's basically like a monster attack type. And then we also have player, which I'm gonna do just this. And then we have targets is like who is eligible to being attacked, who can be attacked by this attack. So I guess targets or target. And we'll just do enum monster player. Yeah, let's just do that. Fine. All right. Now here, attack hitbox rectangle. I mean, this could be generalized into attack hitbox rectangle, and we get the attack is an attack component. I guess it could be like that. Body direction, we can get that, so we don't really need to pass that. All right, so let's see, where's that called there? Update attack. Yeah, there's a lot of things going on there, so you have to sort of make do here. Body direction, AI attack type. Yeah, so the rectangle, if we don't have the rectangle, we return false. So this could be like the first thing we actually do. And we need the registry. We need the entity. Attack component. That's it. And I know this will fix itself, but I'm just OCD now. View. Oh yeah, this is attacks. All right. ABB. Oh yeah, we need CGE. We need ABB. There we go. Body, we can get that, so we'll get the body there. Get const. I don't know why it's const, but okay. Attack type, so okay. Now, right, so the attack. Now this is all gonna be like if, like we switch on attack. And the type is player, we do something, type it monster, and we get the monster attack out, and now we can do this. Right, so we'll do that. That's fine. We need the attack type, I think. Attack type. Or attack. No, yes. No, attack source. We'll do this actually. Make that a little bit more like name-spaced. So this would be monster, well, attack source monster. There we go. Alright. So now we can call monster attack hitbox rect. There we go. Oh yeah, that's right. Oops. You need to be. Well, let's just return there. All right. Well, what the fuck? Okay, sorry. What am I doing? The hitbox, as I said before, should probably be stored here instead. So we just store the hitbox here, and now we don't need to do all this crap. Okay. Well, that was something. Hitbox is gonna be attack hitbox. There we go. All right. Physics system allocator. Do we even need this now? No. This. We need this. We need. Do we need attack type? No, we don't. So let's get rid of that. Do we need AI now? Yes, maybe. We'll see. All right. Entity. Also AI component. Yes. We need systems. Allocator. The diagnostics goes a lot faster now. That's nice. But those are, yeah, I think these are like shallow diagnostics or something like that. So they go really fast. Local constant entity shadows. Okay. So this is the, I'm gonna call this like candidate entity or something. I don't know. Or entity B. Alright. Unused. Okay. Alright. Got all the little things worked out. Now the block check should, I mean, right now it's only happening for the player, I guess, so let's see. If the target is the player, we want to do this. And actually what you could do as well is you can have can block, I guess, if you want to be really fancy here. I mean, you can. I guess you can implement it on attack as well, but whatever. All right, so we're doing that. The player. We only need it in here, so let's move that. All right. Now, okay. So, yeah, what we want to do basically, we also want to see, okay, is the target the type of target that we're looking for? So if target is valid, or if it's not valid, then we continue. Here we do, I mean, technically we should continue here, maybe, or break. I mean, it's the player type, I guess. If it's valid, if it's not valid, we continue. But this is basically only for the player, so yeah, let's just check if it's player, whatever. Okay, and then we break because there's only one player. Fine. But otherwise, we don't really care what type it is. We do health. Was player hit is okay, so it returns like a true if player was hit or shield blocked. Okay. Let's see. I guess we can call this was hit instead. Also, we can neutralize the attack component. The attack enabled. There we go. Yeah, and this would be, you know, the damage. So you can also put the damage in here. I guess we could equal that to 1 maybe. I don't know. And now we don't need this. Okay, cool. And now this should work for both monsters and the player. I think what I need to do is go in and look at the monster version as well to see, or maybe it's the player version, I forget. Yeah. Here. It's a bit different. We're checking for an end of the attack. This is state machine style or stuff. No, but this is updated attack. Oh, so we're doing it there. Check pending. Oh no. Yeah, that's fine. That's correct. Updated. So we're changing it back if we need. I think we don't really need to do this in here. Maybe then we want to do that like outside. Like this is the I think this is like the only thing we want to check here, basically in the end. So we want to move this, all of this, as well into that function here. But I'm gonna let's see, let's move this here. Just mark these so I can, you know, don't forget where it's happening. Player body, player direction, hitbox. So we shouldn't need to get the hitbox, we should already have the hitbox. Do we need this somewhere? Okay, block check. No, because we're getting it down there. Body, we don't need. Okay, damage. We should already have the damage. That is on the attack. Physics system, we already have. Allocator, we have. Intersections, we already have. Freeing, we already do. We're going to go through all the things in here. Now we're grabbing the health. And we are... What are we doing here? Oh yeah. So we have it on the attack, entities already hurt. So we could actually just add that into the attack component actually. Yeah. Let's move this over here. So maybe the neutralize. Well, that's for like the player, I guess. This is for the monster, sort of. But yeah, this is a bounded array. We need to actually... Do we have it here? No? Our own implementation of the bounded array, since it was deleted in 0.15. So there's our dear old bounded array of entities, 32, fine. Alright, so great. Alright, let's go back. So we want to do this. We want to check, okay, is this entity already hurt? Let's add a convenience function there. Let's call this can hurt can damage target. And the target is an entity. Return a bool. So we want to check if it's in our list. If it is, then we return false because we're already hurt that. If the length, so if we can't hurt more, then we also return false. We could also say if we are not enabled, we return false. What else? So if the target is valid as well. Where was that function? I guess we didn't have that. Well, we oh yeah, we haven't done it yet. Okay. But I think that's probably what we want to do. We want to have like if the target is valid or can damage. Well, okay, yeah. No, let's just have them separate because we maybe want more other effects happening or something. I don't know. Okay. Is valid, target, bool, and we need registry as well. So we're gonna switch on target, no, self, target, yeah. If it's the player, we wanna return has player component. Otherwise, it's gonna be a bit harder actually, because we don't really have a tag for monsters now. We used to have like monster area component, we know it's a monster, but now since we're removing monster area component, we have to have something else. I think it's pretty easy actually though, because we can just go into our monster utils and add monster tag and then in init monster, which is then common between all monsters, we simply add to our entity a monster tag. We can even add a function called isMonster. I like that. Entity, and then registry has monster tag entity. There we go. So now we don't even need to export it or anything like that. Okay, cool. And if it's a monster, then we can return. Okay, so now we can switch this around, have return over here. Utils is gonna be actually we can do monster utils is monster targets. There we go. Can't have a target. This is targets. Intersections. Alright, so yeah. We can also say now, let's see. Like here, if can damage target, then, well, if we can't damage target, we will continue. But otherwise, we will sort of register this entity has been already hurt by the attack. No, entity B, sorry. Entity B. I guess we change this to target, make it a bit more readable, I guess. And then we do the hurt thing. Alright. We don't break here because we might have more targets. And we don't really neutralize either here. Like if the player was damaged by this attack, we won't get damaged again because of this. So we don't really need to neutralize here. This was only a behavior for if the monster hurts the player and we need to like neutralize the attack. Here we actually do neutralize the attack because we block it. So then we like the attack essentially goes away, or the damage part of it at least. All right. Okay. And then somehow, yeah, for some reason return true if we were hit or shield was blocked. Don't remember why we do that, but I guess we'll find out. Okay, so now we can remove this part. Okay, I think we've generalized now attacks with for, you know, both player and monster. And we have a special case for player here, if you can block it, which you can sort of move out into a separate function, or move out into a generalized concept if we need to as well. But okay, let's see, update that. Yeah, okay, so that should be it. Now the only thing remaining is replacing our current system of creating these attacks or dealing the damage with just adding an attack component. Now the entity that actually gets the attack component, I guess, doesn't really matter. We just need to have it on separate entities in order for these to be, you know, have multiple attacks, I guess. I mean, technically we could create a new entity with only the attack component added, or we could add the attack component to existing entities, like maybe the entity that actually attacks. It doesn't actually matter. The entity is not actually used. Okay, we are. I'm sorry. We're using it for direction here, but I think that's it. The direction is the only thing we're using it for, and we're only using it in case we block. Okay, so it should be set to. It should be, the attack component should be added to the entity that actually creates the attack. So then we kind of know the source already, but it's also nice to have this, I guess. I think, yeah, we do want the attack type as well. All right, let's see. I mean, and then also you could add attack type to player as well. There's like different attacks for the players as well. But okay, let's see. Now we go back to, let's go here first, the player, and we go to where we removed a bunch of stuff over here, update attack. I think this is fine. This is the only thing that we need to do here. However, at transitioning into attack, we need to create an attack component. So let's do that. Actually, I'll take this back because we need this attack hitbox thing. Now where's the handle state change thing? Where's that happening? We have update. We don't have that. Wait, I'm pretty sure we have like a state change thing somewhere. Play component, set state, attack. No? What? Wait, what? Oops. Sets, oh, it was separate line. Yeah. So basically, whenever we want to set the state to attack, yeah, that's so. Okay, so maybe we didn't have handle state change in the player before. Maybe. I think we only had it for like updating animations. Yeah, probably. Okay, so this is the place where we need to do this. Well, one of the places, I think. Let's see. Is this the only place? No, this. Attack type. Charge attack. Oh yeah. Wait. Why is this not filled in here? I'm pretty sure I did the charge attack thing. Okay, anyway, this is basically where we do the attack. Attack input on, attack misery. Okay, so we have a charge attack, we have the normal, combo, and stuff. Alright, and then we're checking if we have one, and then we're starting up this, we're setting the state. Here we have like a launch deck, but we don't really use that, so I'm not gonna worry about that. Okay, so this is the only place we need to worry about. So here's basically the place where we enter the attack state. So here we could technically also create the attack component. So we could just do this player is as game.player, and this is game.registry. Attack component doesn't exist. We need to import that like this. I'm not getting like auto completion there. Okay, whatever. Attack component. Alright, so what do we have? We have target is monsters. Hitbox. Now this is gonna be interesting. It's like component get attack. Where's attack hitbox? No? Okay, so this is where we actually need to get this thing. Where's the update attack? Player attack hitbox right. Player system. Okay. It's a bit it's a bit all over the place. Oh, we need player body, player direct. Okay. Do we have player body? Yes. Player direction. And attack type. We do have attack type, but it's at AT, I believe, at this point. Yes. Okay, so now we got the hitbox. Great. Damage is this. Great. This should be fine. Source is the player. There we go. So now the player attack should now work with the new system. And now we can go back here to update attack and basically remove all of this because it's done in the attack system now. Great. Yes. Okay. And we basically want to do the same thing for the monster as well. Now here we have handle state change, which has okay, it's fragmented a little bit here. Well, it's sort of overridden in certain monster types. Let's go here first. Here we don't actually handle attack, so there's only two things that actually do attack. It's Klet and Stening, I believe. No, it's Battling also. Okay, let's go to Klet first. And here we have like handle state change. Or would not execute. Oh yeah. Oh man, I forgot about this. So we have a whole host, or a set of functions that handles like attack behavior. So we have like should attack. This is when the monster is like idle or walking around, and we're checking if the monster should like attack. And for this monster, we can have like 2 different, or actually 3 different attacks that could happen here. I guess we could still call this function. We get a attack type back, which is used for the type of attack used, you know. And then we execute the attack. This is where the attack gets executed. So we're setting animations. We are creating this attack over here. Now, yeah, so this is what was checked, checked against before. This attack state was checked for that. So where was the thing? I forgot about. Okay, now we're not calling hurt anymore here. I have to check where this was done. Was it also like update attack or something? Oh my god, here we have like a whole bunch of different things. I forgot about this. But this is basically the function we're worried about. Where we actually damage the... Everything else should probably be the same. This is where we need to... we need to call the... well, this is where we need to do the thing. So... Do we have player? No. Wait, no, we're not adding it to player, we're adding it to entity, that's right. Target is now a player. Yeah. And what is the hitbox? Well, it's gonna be this. Oops. You know what? I guess we can just move this into here. Wait, so let's see. If the attack hit or shield was blocked, we want to see if we want to end the attack. Okay. I think this is specifically for stealing, maybe. Okay. All of these, I guess. Yeah, so we can't really check this here. It's a problem now. If we want to end the attack, or no, this is like a hook when the attack has ended, basically. I think you are ending your jump attack, so you're stunned. So this guy is like stunned after the attack. This one does the root thing, I think, or the burrow thing, yeah. So it attacks and then does a burrow. Or wait, no. If the attack is a burrow, right, that's like a weird thing here. I was using like the attack system to make a burrow ability. Irblos is just ending the attack, so we remove this friction thing. Okay. Right, so something that happens at the end of an attack. I guess technically you could have a hook register. If we move this to the state machine version, this would be way easier to implement, I think. Actually, if we look back here, so state machine hand is down here. I was thinking, like, what if the attack happens in the state machine? Because then we can encapsulate that in the state, like in the state function. Well, we could, I guess we could create the attack component. But the problem then is that the attack won't happen until the next frame. Well, I guess maybe that's not an issue. Yeah, we'll see when we get to a thing that has attack, I guess. Okay. Well, basically, I guess this one is like... I think, okay. No. This? Right, this is where the attack has ended. Okay, yeah, should end attack. Here is where... Okay, so this is like... The reason for why this attack might end is because the player was hit or blocked. Okay. Here is like could be a different reason here. Okay. Well, how would this work? I guess we'll just move this for now. We can just move this into the thing. We'll just move this over here. We'll have a little bit of weird thing going on. If was hit or has shield blocked and attack target is a monster. No. Source is a monster and yeah. Try get or else return. Then we do end attack. Yeah, we do all this crap. This is not the same thing anymore. This will not work. We need to call master system set idle. There we go. Okay, so we'll have a little bit of weird thing going on here. Just to make this work. We need T as well. Okay. All right. Player hit or blocked. Yeah, so they attack. So this will be... This is the monster AI attack state. So I'm just gonna assume that it's in the attack state. There we go. Alright. There we go. Now we should have that functionality as well. And we can do this. Wait, does this happen every frame? Hurt stats? No. I think they neutralize. So, okay, yeah. Because this is like happening every frame because... Okay. And what we're doing in here is we will create. So what we'll do is we'll say if since it's happening every frame, we don't want to create this every frame. So we're just gonna say if we have the attack component on the monster, then we just return. But otherwise we want to create it here. Source monster attack type is attack type. Damage. What is the damage? Is 1. Default damage, I guess. Damage hitbox we have, and target is player, and those things we don't care about. Okay, and the rest we can delete. We don't need to return bool. Alright. Cool. So we should create an attack component here. We have the hitbox and everything, damage, source, target, and that should be enough to for the attack system to know what to do with this, to actually deal the damage and stuff. Alright, and now with the update function, we can say that here we'll do attack system. Oh, we don't have that. Update. There we go. So now we're doing that. That should deal pending damage. At this point now, we should know that we have damage. However, the invincible system needs to happen as well. So I think what we'll do is we'll move this over here. There we go. And now we can move check pending damage to that as well. Because in here there's a lot of stuff happening with different states and stuff. So, but this only happens for the old monster AI system. But let's go back to whatever thing we were doing. What actually triggered this from the start? I forgot. Monsters, mossing. Oh yeah, the hit particles and stuff. So yeah, Now there's not a specific state for this, I guess. This is something that is sort of happening all the time, actually. So it's like, do we want to add it to all the state functions, or it's going to be something that's happening from outside? Is also happening while spawning as well. So that is also interesting. But yeah, I guess we'll continue with the pattern that we have. So we can add default, default I mean, this could really be whatever. Default, what would this be? Check pending damage or something like that. Default, yeah, sure, why not? Alright, we get the health component. We will say if we are hurt, I'm gonna start doing this so now I can actually get the thing. If we have pending damage, if pending damage is equal to 0, we return. Let's just do default hurt behavior or something. I don't know what to call this. Damaged. Do I need to add behavior? I don't know. I wanted to add that because it's like a bit more intricate on what's going on. It's like a bit more stuff going on than just a small thing. Okay, so basically, yeah, I want to copy all of this. And we don't have monster AI. This could be a basic. Well, we don't need to do a base. We don't need to loop through here. We already do this, and we don't need you. Check if dead. I guess we could. Well, check is dead. If dead, check is dead. It's better, I think. Has that component? Check is dead. Oh man, time flies here. So if we're dead, we return. Right. So otherwise, if we aggro, we can aggro. I'm I mean, I guess we could add a bool here to say that, oh, we were damaged or not. So we return false here, and in the end we return true. So then we can sort of change the state behavior based on that. So we don't. If we are spawning, we cancel the spawning. This should also be sort of handled. Well, it kind of. This is kind of weird now because we can't really check what the state is. I just realized. We sort of could if we knew what the original state was. Like we could add sort of map to common states like spawning, for example. And then we could sort of check, okay, is it the same? Because it could be different. Like if the function is different, then we can't just check if we're spawning because it's a different function. So we can't really, you know, check if it's equal or not. So but we could add. I mean, I guess we could sort of a very rudimentary way would be to check, okay, what is the name of the function, maybe. But that's not, that's like the state machine. So we'll get this. Now that's a function. There's no name here, okay. Right, okay. How would we check this? Like, I mean, what I'm thinking is we could pass in sort of like a magical thing that checks what the state is. Like, let's say we add, let's say, what would this be? No, but we could. I guess we could bake this into the spawning state. In that case, actually. Yeah, we'll bake it into the default spawning state instead of doing it from here. And here, if we have a stunned state, we will bake that in there. So we just remove that and we'll do go to the default spawning thing and we will check if default spawning or if we are hurt or damaged. There we go. And if we are hurt, then we also cancel the spawning. There we go. So that takes care of that. And I'll just remove this. Oh, there you go. Guess documentation, good reference for abilities and attributes. Okay, thanks. Let's see. Gameplay ability system. Okay, cool. This will be a nice read. Okay. Yeah. Yeah. Thanks. I'll look into that. Let's see. I'll continue a little bit here because it feels like I'm finding a way to handle this stuff. What we need to do though is we need to try get the health. If we don't find it, it doesn't make sense to be damaged at all. So we just return. There we go. There we go. But now the issue is though that this happens every frame. So, well, actually, it happens every frame, but the pending damage will be cleared every frame as well. So it's not an issue. Is knockbackable, so apply knockback. Yeah, this is gonna be. I think this will be like a configurable thing. So let's say we have options here. Man, now this will become an issue as well, because now we need to provide options to the spawning thing as well. We'll leave this be for now. Maybe we'll find something here. Cancel attack if hit. Now this should be something that is for like checked when attacking, or here's like stunned if hit, stuff like that. So these things should be, and then we set the state to stun. This should be sort of baked into the function that actually calls this thing. So I'm just gonna do this stunned if hit as well. So like these things that are previously like configured, we should just have that in the state function instead. And this should be default though, creating hit particles and playing the thing. So yeah. Why are we not doing this up here? We don't return or anything. That should be fine. There we go. So we're playing a sound, we're creating some particles or whatever if we're hurt. So basically, yeah, that's it. And the only thing now is like the knockback thing. And I think what we're gonna do is we're gonna copy this function over here, the knockback function, which is this one. We'll move it over here. There we go. And we don't have the player. We can get the player though. Knockback strength. Ooh. What is that? Okay, that's just the default. Oops. Default knockback strength. Alright. Alright, so that's the knockback thing. Now I can call that from outside instead. Okay, so now we go to our thing. Default walk. I mean, you could also put it in default walk, I guess. Every monster is sort of going to be damaged. But I'm gonna put it here for now. So it's basically this now. This function's responsibility of handling being attacked and being able to be attacked as well. If you have like states where you need to be not where you can't be attacked, then you can just not call this function. So this would be default damage behavior, and if this is true, that means we have been damaged, and so then we call apply knockback, and there we go. Let's try this now. Like dead. Let's see. Dead. State.dead. Okay, so that's a state. The state is dead, you can't be attacked. Yeah, exactly. But I have a like the death thing here is a little bit different. I'm not sure if I gonna have like a death state, because what I have is like a death component that I add, which marks that okay, this thing is dead, and that is like generic for all entities, not just monsters. Because right now monsters are the only thing that has this state machine, but that could that could change. Okay, player 673. If this turns out to be like a godlike pattern, then maybe I could implement it for everything. Unused. Okay. Attack 61. Update attack. Value of bool ignored. Oh, but you should not return a bool, I don't think. There we go. '86. No field member name. Target is valid. There we go. Okay, I put this in the wrong place. Is target valid? I guess we could call this. But yeah, technically I could just call. I do have that check, which is like generic now for. Like if we go to here. I'm basically checking it here. If we have the death component, that means we're already dead, so then we return false. Or then, yeah, then we're not able to get damaged. Can damage target. What, 47? What's the issue here? Non-void. Oh yeah, so we return true. Attack 122. Expected. Oh, right. Should be another one of those somewhere. Set idle is not marked public. That's easily fixable. This is also a pointer there. Expected type bool. Oh, return false. Right. Monster 952. Expected void. Yeah. Oh, is it done complaining? Yes. Oh, it's no, it didn't crash. It just took some time to load, I guess. All right. Let's see now what we've got with this monster here. Okay. Spawning. Okay, so knockback works, hit particle works, and then it crashed. Interesting. Oh yeah, also I got to switch to gamepad 0 Pro Control every frame, so I need to look into that as well. But this crash here, set add. Oh, we're adding an attack. Oh. Okay, this is actually quite an issue because, yeah, the register system, like the ECS system, does not allow multiple components of the same type on one entity. So, well, I guess one way to fix that would be to add an array instead. Like you add maybe an array list, or yeah, or maybe like a bounded array or something like that, with a number, like maximum number of attacks. Maybe it has to be like a type that is consistent, like this. It's the same type. It doesn't change like type parameters or anything like that. You can't have like an array with, well, you can have a slice, I guess, as well, but then it's kind of harder to work with. Because it's gonna be like, if you have a one monster that does several attacks, let's say, now all of a sudden you can't have that. Is that all attacks needs to be like their own entity, which doesn't really work with how I've set this up now. So I probably need to change this into an array instead. I mean, we could also change the inner workings of this. Maybe. We could do this. Entity. And then the attack is an attack component. Okay, so we'll manage it from here. We'll do this. Yeah, so we can get the attacks, create attack. Yeah, so we'll use this instead of a view. But then how would we get the entities? No, we don't get the entity. Well, the issue is that when the player attacks, there's the attack kind of lingers. Like there's a hitbox that lingers, so the attack survives for a couple of frames, or 1 second, or however long it is. But then if you do a combo attack, you can attack more quickly and attack like 2 times, and so you have 2 attacks at the same time. So, and also for monsters, it's probably gonna be like monsters. We're gonna have to support monsters that have multiple attacks at the same time. But we still also wanna... Well, actually, that's what we have the source for, right? We have the source. The source is gonna be... yeah, so we can have the entity here. Yeah, we can do this. Okay. That should be fine. So now instead of... but we can still have this. That creates a new entity. Attack entity is created. Yeah, this makes sense. Yeah. This makes sense. You can check the time and calculate if it's a combo or not to make the count 1 if not. Well, yeah, I think for the way I've set this up, I need to sort of create separate entities for each attack, because in the ECS system you can't have more than 1 attack component at one time. So that was why I was thinking of adding a list of attacks instead of 1 attack as a sort of component that you can have. But now, after some duck programming, I realized that, well, we could just create a new entity, because the whole problem was that the entity we create the attack component on has the information. In case it's a monster, it has the information in the monster AI component that we need to do things with. But we could just store it in the source, attack source, which is here. So now we have the entity in the attack source, so we don't really need the attack component to be created on the source entity. We can create a new entity and add the attack component there. So that circumvents the thing where you have to have 1 attack component for each, or that you can only have 1 attack component for each entity. And so we'll just create for the attack entity now, we can create an attack. Well, yeah, we'll just add this in there, and that's it. That's yeah, that's what I was thinking there. Yeah, but it might be I have a very I just added things as I move along, so it's like it's probably not very. I mean, I feel it is. I need to sort of make these refactorings to make this more convenient to use, because it's gonna just be a drudge otherwise. Yeah. So your suggestion there, it tells me that there's maybe some easier way to do it, but I don't know. The way I've set it up now is different. I think, unless I misunderstood something there. Let's see. But now I don't really have to manage different. I can just spawn the attacks. It doesn't really matter. Because they are sort of consumed once it has hit 1 entity. It remembers that, so it doesn't hit the entity again. So it doesn't matter how long the attack is up. It can be up forever. Still doesn't gonna. It's not gonna damage the same entity twice. Okay, but whatever. So let's see. Where did I went here? What did I do? Yeah, I created the. Okay, so this is the way we do it now. And then down in the system, we can't use this entity to get like, yeah, the direction, for example. We need to get this. We need to use the source now. Actually, the direction is not needed until we're down here, so we can. We can do this. Hitbox is also like that. Usually allocator first. Find intersections. These ones over here. All right. Let's see. Is target valid? Blah blah blah. Direction. Get const. I mean, we're not changing the player direction either, so that could be get const as well, I guess. Doesn't really matter. But we're not getting it from entity, so we're getting it from the source, which is a monster entity. There we go. All right. Oops. This is attack hitbox. Create attack entity unused. Yes, we don't need that. All right, so now we can use that instead. Wherever we do attack component. So here we're gonna say create attack. There we go. Alright. So that was for both monsters and the player there. And yeah, but then this should work the same because we're still looking for attack components. Yeah, but now they are like separate entities, so we can have multiple attacks from the same source. All right, let's see now. Oh, we got some compiler errors. Monster 955. Oh yeah, so now we need to provide the entity as well. Oops. Which is something, entity or monster. There we go. Yeah. All right. Would be really cool if this the state machine thing. Yeah, once you get like the functions up and running. Whoops. Okay, now. Okay, there we go. That was. It felt like I should have hit this person or monster. It's still like okay. Yeah, it's still like doing the update when even though it's dead, so maybe there should be like a dead state. But that was kind of weird. Like I felt like I hit it, but it didn't register like the first time. I don't know. Okay, but then that works. I'm also gonna try and spam the attack. Yeah. So that works. Cool. All right. Now, what else are we missing here? So we are default damage behavior. I mean, I guess if we're dead, that should probably be like a separate state now that I think about it. It should just be, you know, like default check dead behavior. Yeah. But it's weird because it's kind of like a separate system. How did that work before? Because you could still have like a walk state. I mean, I guess we. Oh wait. I think we checked it here. Yeah, we just check it. Doesn't matter which state you're in. We check it at the first thing we do. If we're dead, we don't do anything here. Okay. That's something that you really can't do here. You have to sort of, every state, you have to implement a separate thing. So because it feels weird that they have to do this, like if check is dead, then this is dead. Okay. And we don't do anything basically. It just feels bad. I mean, I guess it's like a one-liner and it's gonna get copied everywhere. But it just, I don't know. This is gonna be repeated in everywhere. Okay, whatever. I guess it's fine. All right. Yeah. The walk state. I mean, maybe there could be, you know, global. I mean, okay. What you could do actually, you could have global is a weird way to put it, but some sort of thing that's get put in every state. Like default behavior. Default behavior is this. And I guess this could be in there as well, because well, no matter what's, so basically what we could put in there is state that is default. That's right. And then here we just call default behavior. Now I actually need to move that in. So it's sort of like a state function, except it's really not. But it is sort of part of this monster state, the state here. But now we only have to define this once. And we can call upon the default behavior here. Okay. And if we need another state, we can add the default behavior to that as well. So if you want to add a jump, you just copy this jump. We still have default behavior, and we get like default jump speed or whatever, I don't know. Something like that. Alright. I was thinking making this like a global default behavior. I mean, it kind of is right now, but it's more like, okay, you can have it here. The point is that it's going to be very configurable. So we have, but it's also yeah, it's configurable. You have total control. At the same time, it's going to be easy to use. That's the point. That's where we want to get. So we have like default spawning behavior. We have. I don't want this to sort of get out of hand. That's what I'm afraid of. Like, yeah. But yeah, okay, cool. Yeah, so now we can remove this one. Is not basically not used since it's sort of baked into the state system. Yeah. Now it should be sort of the same. Duration ended, player hit for a song. Actually, if reason is equal to forest boss spawn, then we do this. You should be able to do this kind of equality, even if this is like an optional, right? I'm pretty sure. Oops, maybe I was a little bit loud. Okay, there we go. There's kind of like a weird graphics going on. It's not really playing the animation. Okay, that's another thing. It's not playing an animation. It works basically very well now, but the animation is a little bit off. Okay, so do we include that here? I mean, I guess. Yeah, I mean, the thing about this guy is that the animation is like the transition is gonna be. Here's the transition to dead. So there we might stop the animation, let's say, and then. But otherwise, it's just gonna be over here. It's gonna be that we just play the animation. But why is it not played? It should be played over here. It should be played. So here we get the animation. Do we start the animation somewhere? What are you? Animation instance. Start will be T. Okay. Yeah, we should start the animation, right? Or maybe not, actually. I mean, it depends. I guess it depends. Animation, initial animation. Start. If options start animation. No, if wait. Animation info start, then we start it, okay. And then over here we're gonna say wait. No, but that, no, okay, no, this is wrong. This is wrong. No. This animation should start when it's transitioning from spawning to, yeah, it should change to here, so it should be, so what it, yeah, it transitions to walk. I guess we could have a function called spawn, which is sort of the transitional, you could have it like this, yeah, you can have a transitional function actually, you know what, we could have a hook instead of setting the state. We would just call on spawn. And we will pass these along here. So we'll just call this here, right? On spawn, and then we'll have this here on spawn. Okay, cool. Because now we can set the state to walk, and we have a sort of transitional thing. So this is when we are spawned. We set the state to walk. We also set animation to yeah, I don't know what it's called. Maybe walk. Start is true, looping is true, and T is T. All right. I'm just gonna double check what this is called here, so we don't. Let's see. Mossing is somewhere there. Oh wait, no, I need to go to animations. Oh yeah, I do have plans to extend the editor also, which will help with this new system that we're working with. Okay, so walk is walk, yeah. And yes. Okay. Cool. So now we have a transitional here, like on spawn we do the walk thing. I mean, I was thinking like if we have like magical functions like pre-walk, it will be a one-time function that we call when the walk is applied or something like that. I don't know. But no. Because then it's like, okay, it's so magical. I really want to move away from that type of thing. It's really, this is so nice, like this kind of, this is so like how do you say it? Flexible. This system, just having a function pointer that is like the update function. That is so genius. And I mean, I'm not saying it's not me that came up with it. It's someone else. Just so we don't think that I'm calling myself a genius. Anyway, but it just feels so nice to work with this this kind of system here. I mean, it could be that the grass is greener on the other side as well, but at least the initial thing is really nice. I mean, it's kind of like it could have been the same in the other system, maybe, like if I started to, you know, refactor everything out into separate functions and then we can call those and it would look way nicer. But however, I think also this fills in another function, so to speak. No pun intended. As I've said, like, you see the entire behavior here. There's nothing that is hidden, which is extremely nice. So from this state, in this state machine, you have access to everything that is going to happen here in this state machine. So yeah, the state updates, which is really nice also because before there was a lot of places where there was like this generic override stuff, and you couldn't really. Also, the LSP had trouble, you know, getting around and finding the different places. You have to search for where is this function called and whatever. Now, everything is in here, and you can jump back and forth however you want. So it's like, yeah, that is also a huge upgrade to the previous system. Okay, let's see. So now we're on spawn, we're setting, we're initializing, we're starting to do this walk animation here. So let's see how this looks now. Maybe I'll start trying to start in that area as well, so I don't have to move all the way over there. Yeah, I removed the combo thing, that's right. Oh, it's spawning all the way over there now? Wait. No, that's not correct. Initial, waiting to spawn. Right. On spawn is this guy. Why is it calling it immediately? So basically what happens is where this seems to be happening. Wait, spawning state. Yeah. This seems to be true immediately. That's very strange. Like, we're setting the state to initial here, which is this. It's nice that it jumps here directly. All right, I'm not sure. Okay. Why would it happen immediately? Okay. First off, I wanna go here. Move to this place, and here's the start over here. I mean, fine. Okay, now everyone. Oh, okay. Wait. Why is the animation playing? Yeah, I thought I removed the start animation thing here. Start. Wait, it is. Why didn't I remove this? I'm pretty sure in my mind I thought that I removed this. Okay, maybe I accidentally pressed undo or something. I don't know. Okay, let's go back here. There we go. Okay, that makes more sense. Oh, can't make that. Can barely not make that. Okay, the hitbox, I don't know, it feels a bit weird now. Also, that guy seems to have died in 2 hits. I think it's something to do with... I don't know, actually. Something to do with something. Yeah? Did you see that? Interesting. It's like if I jump. The hitbox is like way off. Okay. Okay, but yeah, that's a separate issue. So, yeah, it seems to be have to be aligned on the ground to make it work. But it does work now. You know, we have a death state. The thing gets destroyed and stops walking, and the walking animation is played. So, yeah, that works pretty good. And this is entire state of that. No, not this one. Here. Sort of the overview, you could say, of the thing. It almost fits. Well, it does fit if you remove the sort of thing here. So it does fit on the entire screen. However, it's not that much state, you know, it's just walking and spawning. We have some default behavior. I mean, I guess technically we could move this default behavior into a thing. I think this could be called like default like damaged and death behavior or something like that. Move that into here actually. Yeah, I think I move this here. Make this into... It should really... Well, I guess... default death and damaged state machine. Actually, no, this would be a function which is a type. Struct and this would be check death and damage. We can have options here, so we can have like yeah, I guess we can have options, death and damage options, knockback, and I guess this is like default knockback. And then we have on death. No, state function. Okay. And then here we call options on death. We need to pass T along there. And here's like if we're damaged. I guess we could also have like on damaged. Is that too many? Like, is this beginning to be a bunch of hooks now? Is that? I mean, is that bad though? It's kind of like the on death hook is basically okay. Now we have a way of handling the state transition. I mean, I guess what you also could do is return a. You could do a. Oh yeah, I've done this in another place. So instead of passing a callback, what you could do is you could return a state, a kind of like a result here, which is like death and damage result. So either you're dead or you're damaged. So here we would return damaged. Let's actually let's remove knockback from this for now. And otherwise we return none or null or something. Yeah, we return null because nothing happened there. Or maybe not none. I think it's better to have one switch that instead of having like an if and we check if the value, then we switch on it. Instead we switch on the value. Results is a enum dead damaged none. And also again, what's good about this as well is that if we need state attached to any of these, we can change it to union enum and attach state, and then you can pass some state as well. And now instead of having this as like a, I guess instead of having this as a function, a type, like a generic type function, we don't really need it to be one now. We can just have it as a function like this instead. 1 second there. All right, let's see. Okay, cool. Right, these are not used, So we don't really need to have them in that case. So let's just remove these. Okay, there we go. Check death and damaged. Yeah, so yeah, I mean, I guess we could have this for now. We probably want to, you know, change some stuff around here as well. But this, it should be fine here. Okay, so now we can go back here and we can say, I mean, we can still have like default behavior, but we can now we can say mu check death and damaged. I'm not sure if this is like better, but it's like, what if we switch on this and say if we're dead, then we change the state to dead, and we can also have like state transition behavior there if we want. If we're damaged, then we wanna apply some knockback. Otherwise, we don't do anything, right? And we don't really need this, so let's remove it. Default behavior. That could be a way to do it also. Yeah, there's a lot of ways to do this. I mean, now that we have functions that basically we can, this opens up so much. We can do so many different weird patterns and stuff. I'm just wondering if this is a good way to do like default. I want to basically maximize reusability while also making it visible here what's happening. Making it possible here to, instead of having an on death hook, it's gonna be like you get this event basically, and then you transition to dead state, but you can also do like on the transition, on the edge of this being events being emitted, we can also do stuff as well. Damaged, we apply some knockback. That's also like an event that happens once basically per damage instance, you could say. Nothing has basically happened. This is doing that. I mean, you could do this. You could also just call these functions yourself. Like that's basically the same thing. Yeah. It's just that I'm basically moving in circles right now. Drop item and stuff on that. Yeah. So yeah, that is right now. That is sort of done with a different system. So it's actually just the matter of adding. Where is it? Well, I do have like a configuration for it here, so I can say drop on death, and then I will have this drop on death component that you can add different sort of types of things that you drop here. So here you can have, wait, no, init, right, entity type. Okay, well, whatever. So you can sort of do it there, but it would make sense to have it here as well. But then we're kind of moving the entire ECS system in here regarding monsters. It's like, where do we draw the line? It's like, do we want to use, like right now it's like a mix of both ECS and this state machine behavior. So it's like some things are done using the state machine, other things are done using the systems. So yeah, it's a little bit of a mix, right now. And what I'm thinking right now is like all this should be things that are only for like monster AI basically. That's basically what I'm trying to do here. But I think, I mean, this is just as good as this. It's just in a different format, you know. And here we just have to call one function. Here we have to sort of remember different functions. But then we can also mix and match. We don't have to call default damage behavior if we don't want. We can replace it with something else. This kind of forces you to use the default one because we are sort of doing it here. So I guess this could be called like default death and damaged. And you know, if we want to change it, then we have to go in here and sort of move things around. But it's gonna be harder though to implement things that will affect all monsters, because then you have to actually go in. That's one major downside to this. It's like if you want something to affect all monsters, you have to go in and sort of change all of the states in all of the monsters. Unless you have something that is truly global that you implement. I mean, I guess in that case, maybe that is better as a component with a system instead than in the state machine. So, yeah. Alright, but yeah, I'll stick with this. Default behavior, dead, we don't do anything. That's end of the line. This is like very metaphorical here. This will also be my update function when I die. In the brain at least, like the body will be decomposed and stuff, but on the gas you can have a way to group enemies and they share attributes. Okay. Yeah, I would have to look up how they structure the thing. But are they also using like a state machine? I mean, I guess they have state and they have some logic that... I mean, I guess they don't use functions like this. The point of this, as I said, is like... As I said a couple of times, I don't want to sound that I'm repeating myself all the time. But again, the point of this is like... Here's the walk update function. In here is like everything, basically... that is happening, that is, you can see everything that's happening here that is to do with the monster AI. So if it's not in here, it doesn't have anything to do with monster AI. Now dropping items on death is a separate thing, but and also like taking damage, well, here's you actually do apply knockback on damage actually. So that is kind of like sort of behavior. I don't know. It's hard to define what behavior means, maybe. But yeah, we play some sound and we create hit particles. Yeah, that's it here, basically. But it is sort of what's going to happen if you're damaged, what's going to happen if you die, except for spawning most like items. They don't handle state, it's more attributes and modifiers and tags. Sorry, they have attributes, modifiers, tags, and queues. Okay. That sounds sufficiently complex. attributes, modifiers, tags, and queues. Okay, so I'm taking tags, or basically things that doesn't have state, maybe, and then just an enum that gets on there. I don't know. I'm just guessing here, because attributes, modifiers, and tags basically sounds like three things that are basically the same thing, but maybe they serve a different purpose. Queues, like that's basically like state, I guess. Tags are checked to verify if the modifier. Tags are checked to validate if the modifier is applied. Queues are stuff that happens after the modifier. Okay, that sounds interesting. Sounds way more complicated than I was. Okay, maybe we'll look at this a little bit. I will look at it. Maybe I will get some inspiration. Let's see, because I'm now I'm getting more more curious when you're typing it out here for me. So someone read this. Tranek. Tranek. I don't know. -105 gameplay ability system plug-in gas with a simple multiplayer sample project. It's not official documentation. Neither is project nor myself or affiliated with Epic Games. I make no guarantee of accuracy of this information. The goal of this documentation is to explain the major concepts and classes in gas and provide some additional commentary based on my experience with it. Tribal knowledge of gas among users and okay. That's usually how it goes. The sample project and documentation current with unwritten authorities. Yeah. Battle test and AAA commercial games. Level-based character with skills, option cost, cooldowns. Gameplay abilities, attributes, effects, tags, queues. Okay, so gameplay abilities, level-based characters, character abilities or skills with optional costs and cooldowns. All right, manipulating numerical attributes belonging to actors. Applying status effects. Applying gameplay tags. Spawning visual or sound effects. Okay, yeah, I think I see. Replication of everything mentioned above, right? So, in multiple games, ability activation. Well, I'm not doing multiple games yet, so I'm not gonna sort of get into that. Okay, so it's in the same thing. Float values defined by destruct. These can represent anything from an amount of health. Okay, so this is sort of the state, maybe. What, do they have to be only like floats? Okay. So that, okay, so it's to do with ASC. Wait. What's the ASC? Ability system components. Okay. Attribute set. Responsible for replicating attributes of max for replications. Section on reps how to find attributes. Don't want to. Okay, well, I think a lot of stuff in here are probably like way too like way too hardcore to be sort of for my engine, but it's still nice to see sort of the structure that they have here, and thinking about, you know, a different looking at a different structure here. Yeah, because it's multiplayer. Yeah. Vessels through which abilities change attributes, gameplay tags on themselves and others. They can cause immediate attribute changes like damage, healing, or apply long-term status buffs, debuffs, move speed. Alright. Data only class defines single gameplay effect. No additional logical cues should be added. Typically, designers will create many blueprint chakras. Yeah, so I mean, basically, I don't really need to worry about multiplayer stuff. Like my state functions are, like for one, I don't need to worry about multiplayer. That's a huge thing. And for two, I don't really worry about multi-threading either. So I'm basically doing the most. I have a lot of freedom in what I'm doing. So because it's like it's a single player, very simple sort of, well, it's a I guess kind of simple engine, so it doesn't really need that much power and stuff. It doesn't need multi-threading, you know, unless you're on I guess maybe like a 15-year-old computer or something, I don't know. But no, the bottleneck is the collision detection. Yeah, right now. Okay, cool, but the effects are like that. Okay. What about tags? Hierarchical names, paragraph. Oh, okay. Classifying, describing state of an object. For example, if character stunned, state debuff stunned. Right. You'll find yourself. So kind of like the, what you would say, like the type of component. You'll find yourself replacing things that you use to handle with booleans or enums with gameplay tags. You will find yourself replacing things that you used to handle with booleans or enums with gameplay. Right. What about how long the stun is? Is that like an attribute or an effect or something then? When giving tags an object, we typically add them to its ability something. It does one, the gas can interact with them. So okay, so this is, it's sort of like an ECS, but they have like different types of components, I guess you could say. It is a modifier by time that will take off the tag. Right. Okay, so a modifier. Is that an effect? Is that gameplay effect? Okay, yeah. Typically, right. Okay, duration. Yeah, okay. So you have attributes or floats, tags or basically just booleans or enums or whatever. I mean, they are basically representing if you're stunned or what type of maybe enemy or type of weapon or I don't know, something like that. Type of item. And then effects have duration and can add tags, remove tags, and change attributes. And cues for visual sounding effects. So you're queuing up spawning like visual sound effects. What about creating, like, what about spawning and like new objects? Execute non-gameplay related things like sound effects, particle effects, camera shakes. Okay. Yeah, like projectiles. Or if you have like an enemy spawner that spawns enemies. I guess maybe that's not part of this system. Maybe. The spawn is not part of the system. Okay. Alright, so here we have this demo here. Has these things here. Player state versus character. Okay. Applying, removing gameplay effects, assign from gameplay abilities. Like damage mitigated by armor to change out the gallery. So that could be quite interesting. Like, how does that work? Like, I guess those are effects. So effects are the only thing that can change stuff. So damage would be an effect, but then armor is also an effect. And then you have game execution calculations. So I guess that's where the logic comes in. I guess like handling the effects maybe. You can create calculators that would consider the tags and attributes on both bodies. Right. Stacking effects. I'm guessing this is like the container for everything. Maybe. Attributes set. Alright, so there's a lot of like specificity in this, and I'm guessing that's because of, you know, optimization, the multiplayer stuff and everything. It is nice to have a thing that is, you know, fully thought through, and you know that, okay, I can make whatever I need, but I just need to adhere to this system here. I guess you don't have to. I guess I mean, you could use whatever system you want, but this is like what's a plugin? All right. So only place there we need to increase. Okay. Replication setup. Gameplay tags. Okay. Changes. Tag event. New or removed. Okay, so you can register. Start tag changed. Functions to be called. Okay. Event handlers. Okay. I mean, yeah, that's like the easiest system that I'm using. You can also do that. Loading tags. Okay, cool. Attributes. Okay, yeah. Wait, meta attributes. Okay, whatever. Responding to attribution. Okay, so you can actually add attribute change events as well. Okay. Derived attributes. All right. Now we're like, yeah, that's a concept from like reactive programming. Attribute set. A bunch of effects. Here we go. Because I want to read a little bit on this. Maybe there's some stuff here that I can sort of apply. Or yeah, I'm just curious how this works. Can add execute gameplay cues. Okay, so gameplay effects. Yes. Change attributes through modify. So they can change attributes through modifiers. Okay, here we go. Here's the modifiers. And executions. Right. 3 types of duration. Instant, duration, infinite. Additionally, gameplay effects can add execute gameplay cues. An instant will call execute on the cue tags. Whereas a duration on the gameplay cue gameplay tags. What? Whereas the duration or infinite gameplay effect. Are these like coupled here or something? A duration or infinite gameplay effect will add or remove on the gameplay cue gameplay tags. Right. This are. Yeah. I'll talk about that a little when I get back. But this does remind me of a concept that I've been thinking of for a long time. Like a programming paradigm thing. Add or remove. Execute, add or remove. For temporary changes. Alright, so that's duration. Okay, so instance, just execute. This is temporary. And then this is what isn't this also like infinite? For temporary changes that will remove the gameplay effect is removed. Oh, I see. So then it's like, yeah, it's added as long as this is here. This will never expire. The all must manually remove that bit. Okay. Periodic effects. This also reminds me of Warcraft 3 when doing custom abilities. Yeah. Separate of the ongoing tag requirements, no man. Okay. If you need to manually recalculate modifiers, duration, infinite, okay. Are not typically instantiated with an ability of AC. Once they apply a gameplay, it creates a spec. Successfully applied, then added to a new strike call active gameplay effect, which is keep track of the special. Okay. Applying effects. I mean, for having this varies. I mean, a lot of things here are. It's weird if there's no documentation. Like, there has to be documentation on this. Is this like, why did this person feel it necessary to write all this documentation? Like this feels like this should be like the official documentation here. I mean, that tells me that maybe there is no official documentation. Which is insane for this kind of complex system here. Like, how would anyone figure this out? I guess, you know, if someone, I don't know. Autonomous progress removing modifiers. Okay, yeah, so it's like a, okay, very, it's like programming. Yeah, adding operations, combining operations. Okay. Yeah. Gameplay tags and modifiers. What? Tags are considered only when the effect is applied, when having a periodic taking into consideration further. Okay. Stacking gameplay effects by default. I mean, this is kind of interesting, the tag thing. It's like having effects, but then you have like tags, but the effect is on one actor or like object. But then you have tags on things that kind of filters when they should be applied or something. It's an interesting idea. It's a very configurable way of doing this stuff. It's kind of cool. It's like a very more generic way of describing things. I guess you could say maybe stacking. Granted abilities. Will grant new abilities. Okay, yeah. That's one thing that they can do, okay. And then they can have tags or give tags, remove tags, remove with tags. Okay. Immunity. Okay, gameplay effect execution calculations are the most powerful way for gameplay effects to make changes to an ASC. Like modify magnitude calculations, these can capture attributes and optionally snapshot them. Excuse me. Excuse me. All right. Capture attributes, an optional snapshot. Unlike something modifier magnitude calculations, these can change more than one attribute and essentially do anything else the programmer wants. The downside to this power flexibility is they cannot be predicted and they must be implemented in C++. Okay, so the prediction part, I guess, is also for networking a little bit. Like if the server, like if the client want to display something that is not, like it doesn't need to be transmitted from the server, I guess. Like it only needs to transmit whatever is necessary to display the correct stuff. So if it can be predicted, you don't need to stream every little change. You only need to change or stream whenever, I guess, an effect is applied, or even like the application of effects could be predicted or something. Like yeah, anything that can be predicted basically. Yeah, I'm not that kind of programmer yet. So I don't know, but yeah, it must be implemented in C++. Interesting. Why is that? So you can't do it in blueprints? I mean, okay. Okay. Well, it is interesting. You know, the tags and stuff, filtering on tags, and certain tags are only, like you can apply things with only this tag and stuff. Yeah. Okay. Let's see. Let's see. I'm just gonna grab a cup of coffee here. I'll be right back. Never mind, there was no coffee left. Okay, so let's see. I'll continue for a little bit here and we'll see how much we'll do. So, alright, so I don't need you. Great. So what was the thought here? I mean, I kind of like this. You know, we're hiding a little bit over here, but it's fine. You see, this is the initial state, and you see here, and then we have something here. The problem here is that it might be maybe jump. Like the more of these things is implemented, the more you have to sort of like jump around. I mean, I guess it's true for all of these functions as well. Like a lot of stuff is hidden in these functions. I don't want this to be growing. And to me, it's fine if you have these helper functions. It's I like it, but this is kind of a different pattern than this, which we could have, like instead of doing this, which is really simple and quick behavior here. what I want to avoid is having some sort of default thing that encapsulates everything. Like, I want it to be inverted, because I'm kind of looking at if I want things to be repeated or not repeated, I mean, and also apply to everything, then going for encapsulation is what you could do. It's so easy to get there, but it's like, but then this pattern has broken. So but now instead we call the thing from here, which is what we want to have. Default behavior. It's just that we have to call the default behavior every time. It's not that big of a deal. And we can define whatever default behavior could be for whatever monster we could have. And if there's some state that doesn't need it, that doesn't want the default behavior, we can change it. So, yeah. Like for dead, for example. Very, very simple here. And then the hook for on spawn. This is what I'm contemplating, if you want to have this type of function instead of this, even though this is way less text, and then it's very specialized. You have an on spawn hook that you can call to do this. It's also, you know, easy to understand. Like, you have an on spawn hook. Okay, there we go. There's the on spawn hook. You can also specify more things. Spawning state. Wait. Yeah. Maybe that could be on spawning start or something like that. On spawn is obligatory because we need to know which state to transition into, and then on spawning start could be optional. We could move this in here and have this, yeah, so it's more clear on what's happening here. On spawning start is like if we set it to spawning, but then we can also call options on spawning start. Like, if we have this, we get that, and we can call it with barely enough characters on the screen. And then we can also call options on spawn, which we always have. So then we could change the state to something else if we want here. So it still leaves open the possibility of doing that. But now here we have to say on spawn. Yeah, and that's fine. No. There we go. It might even be a little bit better. We could have like a default spawning state machine. No. And you would be default spawning state machine dot spawning or initial. Alright. Yeah, maybe this is fun. Maybe we'll start here and we will sort of yeah, just move on. I want to implement one more that can actually attack, maybe Cleat, that has a bunch of different states, like attacking, jumping, walking, aggro the player. So it does have a lot of different states there. Yeah. Okay, one thing that I need to look at is, where's the config at here? I want to draw. Where's the attack hitbox stuff? Draw combat hitbox. There we go. Okay, I want to see if the things are drawn. Well, they probably are not. Okay. 31. The walk. Oh, you need T. That's right. Sorry, you need T. That's right. Alright, there we go. I want to see if the... There you can see the player, like the hitbox looks fine. And if we then go to where we draw the stuff, debug, draw, I guess, draw, debug. No? Draw. Draw attack hitbox, monster attack hitbox. So I think we'll do this. And we'll replace this with drawing all attacks. Draw attacks. And we'll get, because now this is different, so we will get attacks is basic view attack, and I will loop through the entities and we'll get the attack, attacks. Get. Alright, so now we got the attack. And that has the hitbox, so we can just say draw system. Should be up here. And then we say draw system, draw ABB. And this is gonna be attack hitbox. And yeah. Then we go back here and we say draw attacks. So that was way easier. Now we could also differentiate between the sources and stuff like that. So technically we could say if it's the player attack, we could have a different color than the monster attack. But let's see if this works now. Okay, so that still looks the same. Oh, it's never removed. Okay. Well, that was a good discovery. Right, it's never removed. So we should have like a timer here. I forgot about that. Yeah. So let's have ends at or destroy at, I guess. Something like this. This would be like an F64. Alright. Now we could add a function as well, which is like should destroy, something like that. T return if destroy at is less than or equal to T. And we will say well, we can have an if here. If attack should destroy T, we return. We don't need to do anything here. And we also destroy, so no, we don't destroy, we do mark for death. Yeah, there we go. Right, so it will be destroyed, and yeah, it doesn't. This effectively also neutralizes it. It doesn't do anything after this point. All right, so now we need to check where we create an attack, which is over here, and we need some sort of timer here. So where did we have that? I think I probably removed that thing. Attack. The duration. Okay, let's go to Cleat and we'll look if there's any like attack. Okay, here we go. Attack duration. So this is like if we are executing an attack, we have that in the attack. So we have it in the attack state. For now. So this would be like AI. Wait. Yeah, because the attacks, yeah. AI dot state attack ends at or something. End at. Or is it hurts end at? We also have hurts at. So we should, yeah, these two we should actually have as well. I forgot about that. Actually, so we should have destroy at. That's when the hurt ends. We should also have. I mean, sure. Let's just call it hurts at. Right. And then we are gonna have another function, which is I guess, is enabled. If we're not enabled, or if we are enabled and hertz at is less than or equal to t. Okay, and then we're checking here if we should destroy, then we do that. If is enabled, or if we're not enabled, we return. All right. Okay. All right, and now we can go to somewhere where we create this. So destroy at, end at, and then we also have hertz at. It's gonna be hertz at. Now I wanna go to the monster state. Where was that? Here, state, monster state, attack. So all these are nullable as well. And so I don't really remember what the logic was there. If we're attacking where we don't have like an end at, does it end immediately? If we have one, okay, it looks here that it's like if we have one, then it's end. Oh, okay, I see. Yeah. Okay, so it is actually a special case where if it's null, it's actually never ending. That's what's happening here. That's right. Because there's a monster that jumps and the attack ends whenever it's landed. So that's what happened there. However, this attack is kind of okay, but that attack is different because it's a jump attack and it's really not a separate attack entity that gets spawned. It's more like the monster itself deals damage on touch is what's happening there. Okay, so it's a little bit different. So basically it doesn't make sense that you would not have an end at, like it should exist at this point. So I'm going to do this. All right. Now hertz at. I think it's like it's never ending then. Like it's hurting immediately. Or maybe okay. Attack hertz at is null. It's not equal to null. Maybe it doesn't hurt actually. Yeah, it has to be not equal to null. So if it doesn't have hurt, then it doesn't. So then it doesn't really matter. It should. I mean. Then this should be like infinite. Okay. Fine. Hurt set, destroy it. So that's the only two things we're gonna have. This could be, I guess technically this is more like Hertz ends at. Actually this would be 0 actually. It's always hurting and then Hertz. Let's do Hertz end at instead. And then this is infinite. There we go. Okay. let's see. Then we have player. No. Create attack. Inputs. Let me see. So yeah, hertz at is gonna be directly, I think. Yeah, let's just set 0 there. And then destroy at is maybe get. No, attack. Attack end at. Is that so? Let's do this. There we go. All right. Alright, so this should make it so that the attacks are destroyed after they're done. Okay, there we go. Okay, now why are these things not damaged? Oh, it's not following the player. I see. So I immediately see what the issue is here. It should follow the player. Okay. I mean, we could do a special thing here. We could also add like the source. We could, oh yeah, we could add a flag here that it should follow the source. So let's do that. So this should be like follow source. And then we should, I mean, it should be like an offset as well. Like we create a hitbox that does have a position in the world. That's like world position rectangle there. But if it follows the source, the hitbox should be like a it should be like a local, like the position is 0. Or if follow source is true, then we can the hitbox could be relative to the player, to the source. So we'll just add that. Yeah, that makes sense. So this should have like if true, hitbox will be relative to source position. Okay, and then the player, I guess we could also we also have to specify the entity there, so that's fine. All right. Let's see. I guess whatever. Let's have it like this. Okay, so now we need to specify that. Now we'll set this to false, I guess. So if it's a projectile attack, well, if it's a projectile, how would it follow anything? No, the projectiles are different. They are not attack components, actually. Yeah, that's like a damage on touch thing. Okay, whatever. Let's see. So, so we're updating that when, so the hitbox, so now we actually need, actually, yeah, we can add a convenience function here that is like get hitbox, and then the registry. Okay, this would be returning this. So basically, if follow source, then we do something. Otherwise, we just return hitbox. But here we return hitbox plus source body ABB or composition. We can do. And we need to get source body from source entity player, it's player monster all right. Now back here, we grab the hitbox. It's gonna be attack get hitbox. So we'll change you into hitbox. There we go. All right. Now the only thing remaining is to make. When we create this now, we need to make it relative to the player. So this should follow source true, and then we're getting the attack hitbox rect, but it should be relative to the player. Not this one adds the player here. So I mean, since this is only used in that function, except here where we're not using it, we should really just remove that and say this is offset. There we go. So now the player attack should follow the player this is center. No wait, actually no. We add this. There we go. Input 565. Text source must initialize. Oh yeah, that's right. So this would be the player. I don't have player entity here. Oh yeah, it's game.player. That's right. There we go. Okay. Very strange. It's like it is dependent on the. Wait, how? Okay. I am confused. Oh, wait. No. Okay, yeah, okay. I see. I see. So the debug is actually wrong. The draw debug thing. So the box is wrong. Yeah. This should now be get hitbox here. Get hitbox. Register. There we go. There we go. Now we're following the player. Okay, cool. Now let's try this out. Okay, there we go. Okay, cool. That works. Great. Yeah, I was worried that there was more behind that, but yeah, that works great. Now I wanna also see, does it work for those monsters over here as well? We'll find out. Yeah. Now what's going on with the... Why are you not being hurt? Oh, because I removed the thing. Oh, yeah. Okay. I removed the thing. Well, that was stupid actually. I shouldn't have done that. This part here, damage player. So this, no, damage player. No, that's not correct. That's not the correct thing. No, it is the attack. Wait, I'm confused now. This should be... Okay, let's see. We definitely hit the other things. So is there something wrong with the hitbox, maybe? Oh, I see. I know what the issue is. The monsters do not have the tag. The monster tag. So let's go here to init monster. And I think from here I want to call monster utils init monster. Yeah. Position. I mean, really, we're gonna get the scene entity here, right? Yeah. We're always gonna have that. This is scene entity. And we have a bunch of stuff. So max health is max health. Draw layer. Alright. So we don't need to do this. We do need to add that. We don't need to do this. We don't need to do this. We simply say damage on touch is true. Is it true by default? Yes. Death settings, we don't need. That's default. We don't need to do that. We don't need to do this. We don't need to do this. We do not need to do this. And we can remove you. There we go. The only thing we need to add is the monster AI component. And I guess, okay, we do need a hitbox as well. There we go. Oh yeah, and also animation. No. Oops. Yeah. Okay. Okay, now this technically should also enable the, this should also add the monster tag to all of the monsters. Also we simplified a lot as well. What is your issue? Oh yeah, now we need to change. This will make it easier also later to change this. We want to change basically out all of these for a entity, like a scene entity, which is gonna be scene entity. And you want a scene entity. So a scene entity animation instance, monster type, max out roll layer, position is not needed. There we go. Alright. Yes. Yeah. Let's just go to the next one. It. Same thing here. Scene entity. Remove you. Change you. Scene entity. Oh man, this is like ancient. Ancient code here. When I did not have these convenient imports. Is this even used? Yes. Okay. This one we can remove. Alright. See. Right. And what else? Right, so now that should be good. Spawn 227. Right, now we just need to pass entity. Very nice. Yeah, I'll change out basically all of these. Always nice to remove a bunch of stuff. Let's remove that. The scale we don't need to pass in either. A lot of brooks small, as we say in Sweden. Okay. Are we down there? Yes. Okay. Now we just need to change all of those. That's a lot of things. I should probably make like a macro here. Okay. You don't need, you need to change, yes. But it is not gonna be that easy. Scene entity. I think I'll do this and I go through each and do that. Okay, there's already done this one. Oh man, it doesn't work. Oh shit, is it because I saved it? Okay, well, we'll do this. There we go. Why doesn't it work? Man. Okay. All right. Let's do the same thing here. Actually, let's fix this while we're here. You need S. Entity ID. No, you need scene entity. There we go. More of these. Yeah, you disappear. There we go. All right. Let's go back here. Oh man. let's do that. These are all, man, so much things here. No, that should exist. I'm just checking here if all of these are actually used. So this one's not used. Okay, good. Right. What do we have? Animation container. System. Component. Direction. Utils. A lot of stuff in here. Maybe do like a search and replace or something. Position. Oh man. Okay. Can we just? I mean, we can copy this and change the position, I guess. Okay. That's also one. I think one of the good parts about SIG, one of the really nice parts is like, if you have any type of struct, like it's so easy. You can just copy. It's just a bunch of data, so you can just copy it and modify it and then pass in if you need to do that. Like if you were using some sort of weird clause where you had like, there was like impossible to change the position or something like that. I mean, that is a sign of a badly, I guess, badly designed system. But it is possible to get into those situations. Or if it's like super, like, yeah, you have to sort of, yeah, then you have to recalculate a whole bunch of stuff, or you have to, you know, use this sort of weird set function or something like that. I guess that could still be true in this, in like, you could have like a set function here as well, I guess, but it's nice. It's just nice that you can sort of, yeah, just copy the data and voila, there we have a new thing. Position. No, wait. No, wait, we have scene entity. Oh, we have it here. There we go. It's now mutated. Oh, it's mutated there. There we go. Let's go back here. This one was done, I believe. Otherwise, we will see it. Okay. Scene entity. Gonna be a lot of boilerplate. Yeah. That one is done. I mean, at least sometimes it goes kind of quick. Okay. It's kind of all it's a little bit therapeutic also to do this sometimes. I think your brain sort of works behind the scenes when you're doing stuff like this. It's like I do want to make a macro, but then I also don't want to make a macro because it's gonna be. Why are these important like this? Because if there's like one little difference, which there usually is, then it's not gonna work, and it's gonna be more work than it's worth. Should really put an L there. Oh man. Same mistakes every time. I mean, that's what you get for copying and pasting. There we go. Let's see. This one goes down. What the hell? What kind of mode did I enter there? I have no idea. What? Wait, hang on. Oh wait, I'm doing it for devices as well. I mean, sure, why not? Position, maybe position. Why would we not have a position? Oh, wait. Maybe I need to undo those, actually. Okay, I'll leave those for now. I mean, this could still take a scene entity, I guess. We'll just do that. Position. It's over there. Yeah. Alright, let's leave the devices alone, I guess. Okay. So this would be scene entity.id and scene entity.position. Because I did change this. No, I can remove the position now. Yeah. Let's do that. Alright. Well, that's good, because now we don't need to do those the same way. We do need to change the signature though. But it's a little bit less. Well, actually, it's probably just as much work, actually. Alright, that's all you. I mean, the items, I did change those as well. Let's change this now then. So this is the scene entity. Right. So this would be ID. Position. There we go. Alright, I think that's probably a lot better to do it like that. Alright. Now we do need to change all these anyway. You have the correct thing. You also have the correct thing. Okay. Explosive wall. Position, we don't need to pass in. It's kind of funny that utils with two, like, I imported the same library twice, but I was using different capitalization for it. It's kind of interesting. Okay. Destructible time. There's a lot of these. No, not that. Oops. Scale we don't need either. Actually, because we have the scale now there. There we go. That was it. Okay. What is that parameter? Draw layer. Oh, I see. Excuse me. Alright, I will probably call it after I've done all this. Let's see. Not that interesting now anyways. Whoops, wait, no, we'll remove you. And yeah, I don't really know what to say now when I'm doing these things. That's why I don't really like doing these kind of things, like mindless stuff, because I don't really know what to sort of talk about. So hang on. Attack type. Okay. Oh, you need that. Or remove you. There we go. You disappear. That's right. There we go. Yeah. Chest. Yeah, it's like my mind is blank while doing these things. And once I start talking, I will also do a bunch of mistakes, which makes it take longer, and yeah. I just want to get this done. It's nice to get this fixed though, but I feel like there's, yeah, I don't know. A lot of boilerplate and a lot of things to update once you change the pattern. Okay. Okay. Scale. Okay, here we go. You position and scale. Woohoo! Oops. I actually have seen it do. Okay, we're at the end. Position. Okay, here, yeah, this is a bit different. ID. Position. There we go. All right, what's left? What is left? Nothing? I am surprised actually. That felt like it should have been more things there to do, but apparently not. See if my controller can connect today. No? What happened now? Don't tell me that it has... Yeah, I've been having some issues with the controller. Probably because it's not supposed to be connected to a PC. It's like a third-party Switch controller, basically. Alright. Right, so yeah. What we did now was fixing the problem here where I can actually hurt these guys now. Okay, great. I'll do a little test thing here, so let's go on an adventure. Yeah, the left button has started to sort of stop register. Even it feels like I'm turning it, holding it down, but I need to like press a lot to make it feel like a register. It would be nice to have like icons. Like right now we could actually implement icons above the activatable target, because we do have a notion of that. Like right here we could have like a, once you're able to sort of go in the door, it could show like a little arrow or something. And then later we can change it to be like the input, the icon for the actual button you need to press in order to actually implement the thing. Or I mean, enter the building or activate the target. Man, I'm getting a lot of the items. I changed the chances to be the weights around, so that the items are way less, the materials are way less like you get a gem 10 times in 12, I believe it's set to. Yeah, it seems to work anyway. I was thinking like maybe something wrong with the calculations. Oh. Time to drink a potion. It's gonna be nice when we have more like I guess, I don't know what you would call it, not quality of life, but I guess more polish when drinking a potion actually shows some like animation and more satisfying attacks or attack sort of effects, graphical effects. Go down here and get rich. What? Okay, this doesn't work anymore. Okay, I need to fix that. Oh man, that felt bad. Why is it so... Oh, because there's a thing up here. Okay. Right, there's a block down up there that I forgot about. Actually, it would be interesting to see if the spawn animation gets cancelled when I hit these guys. It should. But I can't really see it because I can't get there fast enough. Maybe if I jump, I will approach faster or something. And here, like a pickup animation. No. Alright. Did we have anything over here? Yes. No, not up there. Here we go. I feel like these shouldn't really drop anything because they're so easy to kill. Alright. I think, yeah, this is... No, is it in easy mode? Oh, okay, what happened there? Okay, so we got two things. We got a crash in the boss. I will put this down in bugs. Crash. Boss. Okay, let's just do assertion failure, get spawning state. Oh. Default spawning. Oh, I see. This is like created from, okay. Crash boss, mossing types don't have are created. Mossing monsters, boss type monsters are created badly. And then we also have destructible tiles don't trigger on player attack. Probably not other devices either. Alright, but that's gonna be it. So very interesting venture into the world of the new sort of state machine thing there. I'm gonna try and next time I'm gonna try and also convert the monster that we have from beginning, the Kleet monster, and see how it is with a little bit more complex. The Kleet monster has 3 different attacks. It has a jumping state, a walking state, spawning, waiting to spawn, you know, the usual there. and it also has hunting the player state as well. So it has like, I guess it could be, I don't know, it could be dependent on some state in the monster itself, which is like if it's hunting the player, then it has like higher speed, and it's also wanna follow the player around as well. So yeah, we'll see. We'll see how, you know, how that will feel to implement that, and then we'll go from there. And I will also, after I've done that, I will sort of assess the situation a little bit. I will also continue with trying to implement more different types of monsters, because I think, I don't know, I feel like I need to add at least like a big type monster, like a larger monster that is like harder to attack, and then maybe try and balance the monsters that we have a little bit, expand on the maps a little bit, you know, flesh out the first area, more puzzles. Like there's a lot of things that I want to have for this first area. Maybe this first area is the only thing that's actually gonna be in the final game. I don't know. It's, we'll see what happens. But I do have a bunch of ideas actually now that so I'm sort of preparing the development for more things. So yeah. But that's gonna be it for this time. So thank you very much for watching, and yeah, I'll see you later. Have a nice day.